بعلن حمام.
The screen's set at the bottom.
So
it's like right here, perforated. There's 0.25 screen, and it's perforated all the way down.
yes.
From 10 to 200 feet. And so what it is it's got a perforation over a large area to try to get more volume into it. Now a lot of times though, if you're in like a highly productive aquifer, you'll see them only screened for like 5 feet. But this one's screened quite a bit more. The lat longs on this one are 31 degrees, 26 minutes, 35 seconds north.
And hang on just a second if I can, James.
Yes,
the
sir.
lat longs we've been getting off the GPS are degrees and decimal minutes, not degrees, minutes, seconds. So make sure that when you're recording these measurements from James that you realize that they're degrees, minutes, second.
Where's our GPS?
From the GPS, it's decimals of.
We'll give them
decimals of minutes. That's
put
correct.
it right over the top. So like,
We'll see how close the handheld GPS is.
here it is. So 31 degrees, 26.593. And then west, we'd have 100 degrees, 22.101.
You know, that's higher elevation part of the north side. It wasn't
101.
It's like the
Altitude doesn't work. No, don't take altitude off of these because they just lat long, because the elevation on something like that's probably not going to be very
In the
good for
absence
you.
of a total station, the best thing to do is to get the altitude off the topographic map. And I think we talked about this yesterday or the day before. The topographic. Okay.
On the map in the truck there in 10.
Okay, so the contour interval here is, Mahmoud, can you pass James the ruler? That's what we call a folding rule. And it's graduated in tenths of feet on one side and feet and inches on the other. And if you look, the ground is a little bit irregular, so you have to pick kind of a representative place to take your height. And this is what we call casing, and what we're measuring is casing stick-up, how far we say sticks up above the ground. And so you will often hear water level measurements referenced BTOC, BTOC, which means below top of casing. And then you have to correct it to the land surface elevation. And again, we may not know the exact elevation here. We can estimate the elevation from the topographic map. What we want to measure the casing stick up as precisely as possible, just like we measure the depth as precisely as possible.
So this one here is we're going to caved in, and then they came in and they baled it. They go in and they try to get the sediment out with a have y'all ever seen a cable tool rig like to drill oil with or something? It's just, it has a hammer and it kind of shoves down, and when you pick up on it, these little teeth collapse and it brings the sediment up. That's kind of what they use to bale these wells. And then they came in and recased it and re-cemented it. So it's been done twice. It's been completed almost twice compared to what it was originally. Now, that original log that's in my pocket is probably for this well. And so we don't know the perforations now on this one. Who knows? We don't know how deep this goes down or anything. One thing you can do is we have cameras that we can send down these wells and to see what's in them. And so on like this one, where it would benefit to run a camera down it so you can really see where the perforations start and how deep they go. So keep that in mind. There's other things that are wrong here. They are interesting, maybe not wrong, but
yeah, but no two wells are going to be identical.
So we're looking at probably, we're going to measure it there. We're looking at 0.65, 0.7 feet from the ground to the top of the case.
0.70? Okay, so this is graduated again like the we were measuring for the top setting rods for the Marsh McBurney when we were stream gauging. This is graduated in decimal feet as well as in feet and inches on the other side, but we'll refer to decimal feet. The E-line, the electric water level tape, is also graduated in decimal feet. but that is a little bit more complicated to read. So when we start doing this, we'll kind of make sure everybody knows how to do it. In fact, I think it'd be a good idea for everybody to
do their own.
Yeah, exactly, and
we'll
see how
you.
close they are. Yeah.
All right, guys, who's going to be the first one? Dr. Fryer, you want to
Yeah,
go?
sure, I'll kick it. It had a cow painted on the outside, and if you tipped it over, it made a mooing sound. It sounds like that. So, it used to be that we would use measuring tapes, and the tape would have chalk on it, and where the line got dark because of it contacted water, that's when you would record it. This is more precise and less prone to error.
But that still works. They make that stuff. What Alan's talking about is a product called Color Cut, and it turns from yellow to like blood red when it comes in contact with water.
Well, and that's the paste. I mean, what we've used also is just carpenter's chalk. If you know how when somebody is like laying down a plumb line for putting the foundation of a house, and they'll chalk the line and put the line down, we've used blue carpenter's chalk.
Top the line.
Yeah.
All right.
The Color Cut's good because you can get the Color Cut in different formulations, so that if you have a well that has oil in it, such as a well that's been contaminated, it will change one color for oil and another color for water.
I'll show you another use of your field book. When we're doing these wells, to keep that from getting cut is to run it just like that, and you can run it right down the edge.
So what I'm going to do is just spool this out. Now, can everybody see this line? If you want to come in closely, I want to show how you read the line.
Yeah.
So this number here, this says 53, 0053. This is in feet. Each of these thin marks represents 0.01 feet. Each of the slightly thicker marks represents 0.05 feet. And when you get to a whole foot interval, this is kind of tricky to read until you're used to it. 53 feet is actually going to be this mark right here, and then the 0 would be 53.01, the second 0 would be 53.02, the third 53.03, the fourth 53.04, and then your next mark is your 0.05 mark. Another trick with this specific one, remember I said we lost 44 feet of it. We had to cut it off. So all of the measurements we're going to be doing, you have to subtract 44 feet from. So
to make it more complicated.
I apologize, it's just that's the instrument we've got. So
I was like, he hasn't dropped it 53 feet already.
No, I have not. I dropped it 9 feet. So what I'm doing is just spooling it out slowly, hand over hand. And when it hits water, so James, you said the depth of water was what, maybe 80?
54 is what the well log says, but I bet it's closer to 80 to 90 right now.
Okay, so what do you think the reading on this will be just in whole feet when we hit water? What do you think it will read, knowing this particular instrument?
120.
Yeah. Roughly 120. So add 44.
How far are we now, Alan?
101. So we should be getting close, folks. Up. There we go. And sometimes, depending whether there's condensation on the wall of the well, for example, I mean, sometimes the circuit will close and it'll make the noise, but you know, you kind of bounce it, it'll kind of go. This is pretty exact, but I've had instances where I've had to kind of bob it up and down to make sure that I know exactly where it is. Okay, so can somebody read this for me?
Right to the bottom of the book.
Okay, and what you do is you take your fingernail and put your fingernail right on the mark. Okay, so you're right where? Right here?
That's it.
At 8. Okay. At the number 8? Or, okay. Alright, so that's 0.80. So the closest whole number here is 101. So 101 this will count backwards. This is going to be 100.80 minus 44 in this case is what?
So go ahead and write down that 100.
Yeah, write down the 100.80 and then go ahead and subtract the 44.
100.8.
100.80.
So what are you saying here? 100.8 minus 0.
101.
Minus what?
Minus 44. Exactly.
Was it 100.8 or 101.8?
Yeah.
Oh, no, the closest one was 101. Okay.
What do we got?
It was, the closest mark was
56.
101 and we
Gotcha.
counted
Counted
backwards.
backwards.
Yeah. So
56.
56.
Around
0.80.
0.80, yes, record it to 2 decimal places because that's what you're measuring it in. And when we fixed this, I mean, it didn't snag exactly at 44 when it got caught, but we trimmed it to the nearest exact
Whole number,
marking and
yeah.
nearest whole number, and so that was 44 feet.
Now remember, we've missed a major thing on our notes I don't see is we need a date and a time that we're in the field.
You guys have your watch on? Is anybody taking time measurements? I can call out a time for you.
Today's 10:30.
Yep.
10:30 a.m. It's the 17th.
Write down the time. Minute.
Your field books remind me of the field books I saw
Write down
when I
the
was
date.
working in Austin. One of the women who worked there before me was Israeli, and so most of her notes were in English, but when she wanted to write down something that only she could read, she'd write it in Hebrew. So you guys are going to have a mix of Arabic and
Sensation on the outside, and groundwater is pretty cold.
average air temperature around here.
Annually,
Yeah.
I would say close to like, just based off my head, I would say it's got to be about 22 degrees C average.
So groundwater temperature should be really close to that. Groundwater temperature generally is within about 1 degree Celsius of annual average air temperature for shallow aquifers.
Yeah.
If you've got geothermal waters, obviously that's going to be different.
It might be a little warmer, Alan, maybe 25.
So, but this should be in the low 20s, 20 to 25 Celsius here, because the annual average air temperature is in that range, and the temperature, what we call the temperature envelope, the air temperature fluctuations get dampened out as water infiltrates below the soil.
22.1.
Oh, you're good, man.
Write it down.
Just off the top of my head, I guess.
Go buy a lottery ticket.
Yeah, it's your day.
Okay, what's the,
DO pressure.
well,
We haven't calibrated for DO, so
Yeah.
probably don't
the
look at
barometric pressure, yes.
763.6.
700?
763.6.
63.6,
Yes.
and that's millimeters of mercury. Right, HG. Okay,
These old oxygen not calibrated.
no, it's not working.
Specific conductivity.
Okay, specific conductance.
Yeah. 3,481. 3,481.
Millisiemens
A
per
microsiemens.
Microsiemens per centi?
If it's in hundreds, then it's usually going to be microsiemens. If it's decimal, like 0.3, whatever, then it's usually millisiemens.
Okay,
Conductivity 3,311. 3,311.
Is there a decimal point in there, or is it 3,000?
No, 3,000.
Okay.
3,000. Total dissolved solids 2,262.
That is high.
2262?
Yeah.
Hey James, we can do DO
Milligrams
at some
per
point. Do you want to do that here and a couple
Milligrams?
others? Or do you want to do it someplace else? Well, I've only got 3 bottles. That's what, let's go ahead. And hopefully we got enough water. James and I were doing the math. And,
I think we'll be okay.
all right.
Maybe we're not. Ah, bummer.
Oh, we're screwed.
Back down the well.
The capacity of it's like 500 milliliter capacity, and that's a 300 milliliter bottle. So if you use too much water,
We'll be here for
Oh, you mean it's been left open? Yeah, but I can.
See how he's feeding it though? How he feeds it, he just lets it pull off itself. He's guiding it to the floor, Joe.
Heard that.
Perfect. There you go. Oh yeah, we got it now.
Perfect.
All right? It's draining. There you go. Good catch, Gary.
Yeah. There, get the rope out of the way. Yeah, we're good. At the bottom.
Okay.
We know.
Bummer.
Gotta do it again.
Who made this one? They made it 3 inches too short. This one
I pulled it out of my closet, man. That's all. I've got one of the disposable ones, but it's not nearly as robust. That's the one use only.
We're ready.
The good thing we're, well, not sampling from a bunch of animals. And that it's only 8.
Oh man, yeah, we'd have a good day here.
Now remember, you want to let it sit for just a minute or two. Not yet. Don't open it yet. Just wait till he set it down.
I'm going in without you. Alright, someone needs to catch it like I did.
Wow. Muhammad's going to have carpal tunnel by the time this is finished.
Only 50 feet left. Be all right.
Okay, if it's starting to clear at the top there, then it's probably okay to add the reagent.
Oh yeah.
Just y'all are up.
All right,
Catch the
Catch
ball.
to the bottom.
Yeah, there you go.
Nice. Okay.
Oh, pour that water out?
Yeah,
Yeah.
might as well.
There we go. And then now we have plenty.
You want a complete sample.
That.
Oh, let's get the, you can hold the rope right there. There we go.
Yeah?
Little colder. Okay, it's stabilized. Go ahead and read it off. That's 22.1 degrees Celsius.
Temperature's almost identical. Temperature is
It's right at 761.4 millimeters of mercury. 1,826 specific conductance in microsiemens per centimeter. Conductivity is 1,747. Total dissolved solids, or TDS, is 1,189.5. And pH is 7.26. So this one here is closer to neutral than the other one was. This is better quality water. Good.
I think our
Pressure.
TDS.
760, 760.8 millimeters of mercury. 2,306 microsiemens per centimeter specific conductivity. 2,179 microsiemens per centimeter. It's too well to
And then, oh, it is.
So
Okay.
we've already done them.
The barometric pressure is 760.6 millimeters of mercury. And then 760.6. And then specific conductance is
SCC?
yes, S2307